All right, on page 297, example number 2, we're going to explore another method of dividing radicals. So if you remember in multiplying and dividing, it's up to you whether you want to first simplify radicals, then divide them, or if you want to divide them first and then simplify them. So in some cases, again, you can always pick one method. In some cases, it might be easier to simplify a radical and then divide. So class example 2 is trying to show us that another method in there. Again, you can do it either way. So I'm going to do part B. There's nothing to divide the coefficient with, so that will stay as 8. But rather than trying to divide 126 and 112, which you can't really divide out completely, at most you can reduce them. What I'm going to do is I'm going to first simplify it. So going through my list of perfect squares, it just works out that 9 and 14 work out for this number. So it ends up being 8 times 3 square root 14. So that was the top, and for the denominator, root of 112. 112 can be divided by 16. So I'm going to try that. 16 and 7. And that simplifies to 4 root 7. Okay, so what happens is, if you want, you can rewrite this a little bit nicer. This ends up becoming 24 over 4. And that ends up becoming root 14 over root 7. So we can see our coefficients and our radicals, a little bit simplified version of them, and then we can try to divide them out. So in this case, 24 will divide out with 4. It will become 6, and then 14 and 7 reduce to become root 2. Okay, so that's another way of dividing radicals. So sometimes numbers don't quite reduce nicely, like in our previous examples. So they were really dividing out completely, like 18 was being divided out by 3 completely. So it just made sense to divide it out. But when numbers don't divide out really nicely completely, like 54 can't be divided by 8, 126 can't be divided by 112, yes, you can reduce them first, or you can simplify the radicals like I just did here, and then try to see if you can reduce them in the end. So that's another method that we can use, and we will need to use it sometimes. Here's another example. In this case, they're saying divide each term by its numerator, by the denominator, and then simplify. So they're asking us to kind of give back that common denominator to every term. Okay, so that's what the idea here is. We're taking that common denominator, root 5, and we're taking it back to every term. So that's kind of like what we do the opposite direction when we're adding or subtracting numerators and denominators and fractions. So in this case, this method will work because this 5 really divides into every numerator term. So this ends up giving me root 4 plus root 8. And that gives me minus, what does that give me? 90 divided by 5 will end up giving me 18. So again, this method would only work if the denominator divides nicely into each numerator. And then we can simplify this further. This becomes a 2. This becomes 4 root 2. This becomes 9 root 2. I'm bringing the signs down. So 2 plus 2 root 2, sorry, I forgot the root, minus 3 root 2, and that ends up combining. Only these two terms can combine because these are two like terms. This is a whole number, so it will come down as on its own, and that becomes negative 1 root 2. Don't need to really write the 1, but you could just write it as 2 minus root 2, or negative root 2 plus 2. Doesn't matter which option you pick here. So again, this would only work if your denominator divides into your numerator nicely. Next example, we're going to find out what if it doesn't happen, then what do we do with these kind of questions.